Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will try to discuss about a very important topic, mainly deep learning, how we can easily implement the CNN model for classification imagery. So I already published a video about that. Here you can see this is the video about that. I will attach this video link in the video description. You can easily find out this my previous video. So now I will try to discuss about that all of basic concept about that CNN model and how we can easily make the data as well as also pre-processing the data. So all of those things I will try to explain one by one. So if we have no knowledge about that CNN, don't worry about that. I will try to explain all of these things from beginners to advanced level. So I hope after completing this tutorial, you are able to do for any classification. You can easily use the different types of data set. It can be satellite image, drone image, or any other imagery. You can easily classify using your model. So let's go try to start from here. So I already make a post in my Medium. So you can also try to follow this, then you can get all of things about that. Okay, all of things you can easily get from here. So we'll start from here step by step. So here you can see first of all data collection and preparation about that data. So here you can see you can use here the satellite imagery, different types of satellite, Landsat, Sentinel, or commercial satellite imagery. It can be Maxar or World View or sports satellite imagery or any high resolution satellite imagery you can easily use. So such as you can see, you can use here the Euroset as well as also you can use any other kinds of data set. You can also use it. So first of all, we need the data. Okay, so which data set you want to make the classification, you can simply import the data. So in this time I try to show you the example one by one how it will be work. So first of all, you have to install the TensorFlow. So for that, just simply write the code in here. Pip install TensorFlow. So just run the code and then check what happened. Yeah, so it's a pip, sorry, pip. We are using the pip and then install the TensorFlow. So here you find out all of things. It's successfully done. It means that my TensorFlow is successfully installed in my system. Okay, so here you can see it showed about that requirement already satisfied and successfully done it. So now I take the another cell and now I just simply import the TensorFlow library. So just put here the import and call the TensorFlow as TF. Okay, so just I simply import that TensorFlow. So you can see it will be imported successfully and there is no problem about that. As well as I also need to import that some other library such as import that dataset, layer, model, and matplotlib for display this visualization about this result. So just I simply use here the import and then call the TensorFlow. So just I call the TensorFlow. I call the TensorFlow.keras. TensorFlow.keras and further. Okay, so in this time we are just use here the form because I want to use here the form TensorFlow.keras, and from the TensorFlow.keras I import some data set. So just I import some data such as I imported the data sets. So just use here the data sets. Further I want to import layers. It also need for that, and also import the models. So it also need for the different types of model you can easily get in here. Okay, so just I run the code. So now it's about that successfully done. There is no problem. And here you can see about that. In this time I simply import the another things which help me to visualize the data. So just use here the import. I want to import that matplotlib dot pyplot as plt. Okay, so just I try to run the code. Okay, it also imported for that matplotlib. So first of all, you can see I again explain this code here. I just import that, install the TensorFlow, and then further import the TensorFlow and give the short name as a TF. And also from the TensorFlow.cross, I just simply import some data set. Okay, so basically from the cross in TensorFlow, we can find out the lot of data set. Okay, and then we also import some layers and also models and show all of those things. Just I use at that matplotlib library. Okay, so now I load the data. Okay, so basically it have the lot of data set. So load the data and pre-process the data set. So in this time I want to use this data, so I will show you the data from the Google first. Suppose I want to use the data, its name is that cipher 10 data set from the Kaggle. I will show you that. So you can see at the cipher object recognition in image Kaggle data set. So in this time I want to use this data set, and further I want to make the classification. So here you can see about the data, all of those things you can easily get from here. So in this time I just use this data, and further I want to make the classification using CNN model. So let's go, and here you can see I already imported the data set, and this data is already available. Cipher 10 data is already available in this data set. So now I want to visualize this data. So for that, in this time I just simply load the data and pre-process the cipher 10 data set. Okay, and I want to store the data in the train image, train levels, and test image and test levels. So just a simply variable look like that. So just I put a one variable is that train images, and also call the train levels, and then load the data. Okay, so just I write the code in here look like that, train image, test image, and also get the train level and test levels. Further I mention about that data set, and then I put my data set name cipher 10, and this cipher 10 I want to load. So further I use at the load data. So now run the code and check what happened. So you can see it will be loaded. So now this data set is downloading. Okay, all of images. So basically this data, cipher data, all of those things will be downloaded from here. So let's go, we check. Yeah, it's downloading, successfully downloading all of images from that cipher 10 data set. So now in this time you have to define the class name for the cipher 10 dataset. So we have to define the class name from this cipher dataset. Basically we can get the ID. So this, it can be cat, some imagery about that, aeroplane, bird, deer, dog, frog, horse, sheep, truck. So there are the lot of data, so we can easily get from here. And you can get about, click on the data, then you also get about the information. So here you can see about these things. You can also download the train labels from here. You can see, so basically the label of the class dataset are, you can see aeroplane, automobile, bird, cat, deer, dog, frog, horse, sheep, truck. So this is the label about that. So now I simply mention about the label about this dataset. So for that, define the class names for the cipher dataset. So just I simply take the new cell and define the class name one by one. So just I take a variable. Suppose I put the variable name is that class names. So just I put the class names look like that, and then click the run. So now it imported all of them in here. And now I display the first 25 images from the train set and their class name. Suppose I want to show for the 25 images or 20 images. So just I display this train image with their class name. So further I take the new cell, and now I just simply make a plot. So I already imported that matplotlib library as a PLT. So just I put here the PLT dot figure. So just I put here that figure, and I put the figure size. So just I put here the figure size, just right here that fig size. So just I put here the fig size. Okay, and I want to define the range. So here you can see I simply define the range. So for the range, you are just use here the for I in range 25. So I want to display the 25 images in here, and then further I want to make the subplot. So basically I want to take the 5 subplot in here, and then further we are just put here that x tick and y tick. Basically it's the x level and y level, and plt grid I put here the false. Okay, and then further we are just use here the plt image show. Okay, plt image show I just put here the I initially, all of this things show in here, and also put here the legend. So just put here the cmap equal to plt.cm.binary. Then we have to get the more better result about that. So then finally we are just show this result in here as they just I call the plt dot show, then it display this result. So that put a plt dot show and then put the parenthesis. So here you can see in this time I just simply display this result, and I want to first of all I define the figure size. So just put here the 10,10, and then I simply show the first 25 images, or if you want to show the 20 images or which number you want to show, you can simply put that and make the subplot about that. And then we are just put here this the show, as well as we also try to add the class name, because in this time I would display the first 25 images from the training set and their class levels at the same time. So now just run the code and then check what happened. It will be not run. You can see yeah, it's working. You can see you can get this type of imagery. So here you can see the frog, truck, or truck. Also you can see the deer, so automobile, car, bird, horse, sheep, cat, deer, horse. So all of those things we can get that train image, as well as we also get about that their level. So basically CNN is one kind of supervised machine learning method. So for that we need to define the level must when you want to work with the supervised classification map. And further when I talk about that things, suppose CNN model for land use land cover classification. So in this time we will also input some label. Okay, suppose we make the label for build up, vegetation, barren land, as well as also cropland, or which class you want to make the classified. You must need the level data or pre-categorized data, otherwise CNN is not work. Okay, so this is the main condition about the CNN. When you want to classify anything, we must need the level data or pre-categorized data. So now we just try to input that CNN model is just creating here. So for the CNN model, here you can see CNN are well suited for image classification due to their ability to capture. Okay, and CNN architecture for land use land cover classification. First of all, in this time here you can see input layer. We have to create the input layer and input shape. So basically in this time they are use this type of shape. So let's go try to make the CNN model now. So this is our imagery. Here we can find out that imagery and that level. Okay, so further I just take a new cell about that, and now I want to create that build the CNN model. So in this time we create the sequential model. Okay, so just I take a variable model equal, and I put here that models.sequential. Okay, model of sequential is simply put in here. So now I want to add the some layer, such as I want to add the convolution layer as well as the max pooling 2D layer. So all of this layer I want to add in here. So here you can see in my medium, you can easily find out all of things in here. You can see. So you can see we created that convolution layer, max pooling 2D layer, contour 2 layer. So this type of layer we need for when you want to work with that. So now I want to try to add this type of layer in my collab. So just I simply import that sequential model, and in this model I want to add some layer. So just use here the add, and then call the layers, and there also mention about the layer name. So one kind of layer I want to put in here convo 2D, and put here this value, and I want to apply the activation value and input shape. You also define about that this type of input shape. And further we are just apply this parenthesis. Okay, look like that. After doing these things, we also put the another layer. It's called the max pooling 2D. So basically this type of layer help you to create the hidden layer, also help to create the output layer. So just I simply put this type of layer. So just call the model. I already make the model is my sequential, and I want to add the layer for max pooling 2D. Okay, so just I put here the max pooling 2D layer in here, and further I also need to add here the convo 2D layer. So in this time we are just put here that value 64, okay, for the convo 2D. So just I call the model and add the another layer. It's called that your convo 2D. Just I put here the convo 2D. Okay, and activation to the rail we can use in here. Then we put here the max pooling 2D and also put here the convo 2D layer, activation layer, we just convert in here. So this is the process for creating the model. Okay, so actually there are a lot of things for the model in CNN. So from here we can choose the model sequential, and we put here the this type of layer. Okay, so actually it's not, if you want you can also add the more layer. You can simply go to this website, suppose CNN, or you can simply CNN with TensorFlow. Simply search here with TensorFlow. Then you can get all of information about all of layer and how it will be work. You can get a lot of demo about this layer. You can easily get from here. You can see. So this is the main website about the TensorFlow. So here you can see about that all of information about this model and how it will be work. So all of those things you can easily get from here. Okay. So now let's check about that. So we'll just write the code in here. So after creating this model I want to add with the dense layer on the top. So for that, just use here the model. I simply call my model, and then I add the layer. So add layers, flatten. And further we are just dense layer with put here the 64 activation value, and then also put here the only dense we put in here. So for that, just write the code. This code is that mainly I just call the model and add the dense layer 10. Okay, so now click the run. Okay, let me show the problem. So model dot add layers. Okay, let me run the code again. Alright, so the problem name model is not defined. Okay, let me run the code again. Okay, and then further, okay, so now click to run again. So now it will work. Yeah, yes, done. So now it create this model look like that, and further we are just compile the model. Okay, so as well as if you also want to check about the model summary after creating the model, you can get that model dot summary. Now we can get all of summary about this model, all of information. Here you can see we are using the model is a sequential. Okay, and we can get about that all of output shape for each layer. Okay, convo 2D, max pooling 2D, convo 2D, max pooling 2D1. So all of output shape and also that parameter we can easily get. So after creating this model, you can easily check the summary using the summary function in your model. Here you can get also, you can see the total parameter, trainable parameter and non-trainable parameter. We can get these type of things. So basically all of parameter is the trainable. We can get that 0 is the non-trainable about that. So now we are just compile the model. Okay, so for compile this model, we are using the different types of optimizer. It can be Adam, or you can see in my medium. So here you can get some information about that for the compile this model. So here you can see for this time for the compile this model, we are using the Adam. So Adam is one kind of optimizer, and further we also calculate the categorical cost entropy. So it's to calculate the loss and also matrix accuracy about that. Okay. So now we are just applying these things for train this model using the optimizer. You can see optimizer can be ADAM or SGD, RM, SPROP. So this is the different types of things. And loss function basically is the categorical or stentropic for the multi-class classification. Okay, so we have to calculate the loss function. Okay, so now we try to put here all of those things here. You can see. So we can see all of information about that input layer or convolution layer. Okay, so basically in this time multiple convolution layer with the filters, keras, we can detect that. So this is the one kind of example about that. Also you can see the pooling layer. Okay, so we are using the pooling layer at the, in this time max pooling or average pooling to reduce the special dimension about that. Also fully connected layers. So basically there is a dense layer for classification. Okay, and we can get the tens 180 example about that. Also output layer, in this time for the output layer softmax activation for multi-class classification, or if you want you can also use the ReLU function about that. It also okay, there is no problem for the activation. And software is also work well for that multi-class classification, there is no problem. And further train the model, in this time we are trained the model. So basically this type of thing is need for the train loss function. We need the optimizer, we need the matrix. From the matrix we can easily calculate the accuracy, precision, recall, and F1 score. Okay, so basically you can see here, and train process basically split data into two training, validation, and test set. So you already divide the data. So let's write the code for that. Train the model. Okay, so you can see here in this time it create this CNN model. In this time this model I want to apply and train. So how I can train? So for training this model, first of all we have to call the model, and then you can use a function compile. Okay, compile, and I want to apply here that ADAM optimizer, and further we have just call our loss. I simply call that TensorFlow class loss space category store fit. From that true we are just put in here, and also put the matrix about that. So now this is the code for compile the model. After creating this model, compile the model, we are just train our data set. Okay, mainly train image, we are just simply train with that. For that train the model, for train the model you can take the variable name, and this variable simply use fit. Suppose I put the variable name is that history equal, I call the model which I already created. So you can say simply call this model, and fit. So basically this fit we are used for train the model, and I apply the train image and train levels. Okay, so basically we already make the data set, you can see in here. So in your data set we are just simply put here the train and test. So here you can see this is the code about that. You can see this data set, you can see we already take the variable for that train image and train levels. Okay, so basically this train image and train levels we are used for that train our model, and test image and test level we are used for checking the validation. Okay, so for that I just train this model. You can see here I just put here this train model fit, train image and train levels, and further epoch I put at the 10, so it create the 10, and validation data we are use for the test image and test levels. Just we simply separate these two things. So now I run the code again. So now it create this type of epoch. So here you can see, and then further we are just evaluate the model. Basically we check the accuracy about that, what the accuracy can get from this model, we can easily check it. So now I can see it will work. So it create the total 10 epoch about that, all of train image and train levels. Further we just also work about that. So here you can see the medium, you can easily get about that. So basically in the train process what we can do, for the train process we split the data into training, validation, and test set. Okay, so basically train image, train level, then validation is the test image and test level, and train the model using the train data and variable and validate on the validation set. So here you can see it's one kind of example about that. So here you can see we create the model and compile with that ADAM, and further this model will fit our train image and train levels, and also check the validation data. We are just put here the your test image and test level. Okay, so just we fit this model and further evaluation. In this time after finally we check about the evaluation. So access the model on the test data set and calculate the overall accuracy, class wise performance metrics, all of this thing we try to calculate it. So now it will be work. Yeah, so it's done. So after doing these things, we are just taking the new cell about that, and now we just try to calculate about the evaluate the model accuracy. So basically for the model accuracy, we are just applying here that test and also use here that test level and test image. So for that, I just use here the take a variable, suppose test loss and test accuracy, and then I call the model, and I want to use here the evaluate function with test image and test level. Okay, so after doing these things, we are just print this result. So for that, just use here the print function, print this test accuracy. So for doing this thing, just I simply call these things such as a test accuracy. Just I call it, suppose simply copy and paste here and click run. So now you can get this type of accuracy here, you can see. So it show the result for that, how much accuracy you can get from here. So we can get this type of result, as well as if you want to plot the training and validation accuracy and loss, so it is also possible. Suppose you want to display this result, such as just take the new code cell and further you just make a plot and for training and validation accuracy and loss, all of those things show as a graph. So for that, first of all, you try to define your graph size, graph figure size. So plt dot I just simply put here the figure size. So just put here the figure and put the figure size. Okay, so if not, just I remove that. So simply put here the figure size about that, and then in this time I put here the suppose is here the 10 and 5 width and height about that figure. And then we are just create the plot subplot. So just I simply put here that plt dot plot, and then I create the subplot. So plt dot subplot. So just put here the plt dot subplot, and I put here this type of subplot, and further we just call the history. You can see history, and from the history you can call the accuracy and also put the label name as the accuracy, and then put here the history and the value accuracy, and put the label name is the value accuracy about that. And then you can also add some y label, x label. So I simply plt and put here that x label. Okay, I put here the plt x label epoch, and y label I put the label is the accuracy. And further I put here the it also better, I just simply put here the 0 and 1 for that y limitation about that y level limitation. So put here the 0 and 1. So then plt lesson, in this time I put the lower right corner show about this lesson. And if you want, you can also put here that you can also put here the title. Suppose I call the plt dot title, and I put the chart title about that. Suppose I put here the chart title is that training and validation accuracy. Okay, and further just plot that. As well as it show only for the one. Suppose I run the code, so now I can get the result only for that accuracy. Okay, so we can get training and validation, but it show only for that accuracy about that for your that. So in this time we also calculate about the loss. Okay, for the loss we are just use this code for at the same graph, then it also more better. So just I simply create a subplot. So plot dot subplot, plot dot subplot, and I define here the plot figure size, and further we are just plot. So I call the history, and this time we calculate the loss. I also put the label loss about that, and also put the y label. Epoch is the y label is the loss about that, and I also add the another legend. So just put at the plt dot legend, and I put the legend name is that, suppose okay, we just put the legend in that upper right corner, and also put the title training and validation loss about that. Okay, so now try to show this code what happened, and further just put here the plt dot show. Okay, so now run the code again. So now at the same time we can get the two graph. Here you can see in one graph show about that training and validation accuracy, another is show about the training and validation loss. We can easily get the figure look like that. Okay, so you can see the accuracy. Okay, also you can see about the loss. You can get that is the epoch, and also get the accuracy about that. So you can see here we can get this type of things after evaluation, this result. And now in this time you can see here, so we can just calculate the accuracy about that. And fine tuning, we are also use here to adjust the hyperparameter. So basically learning rate, best size, dropout, best normalization. So basically this type of things we are also find out the hyperparameter turning, and then we also get the better accuracy about that. So basically in this time you can see here we can get that CNN. So you also try to explore this type of things. You can also get some free resources for that learning purpose for the CNN. And I already make this video about that for the land use land cover classification using that CNN model. But this concept is the same all time when you want to classify anything about that. It can be any kind of imagery, or it can be any kind of drone image, satellite image, anything. So I again explain this code one by one. So first of all, we simply import our TensorFlow, and then we have just simply imported that TensorFlow library, also TensorFlow.class. From here we simply import the dataset, layers, and model, and then simply import the matplotlib pyplot as a plt. I put the name, and then I call the dataset about the cipher 10 dataset, which is including the different types of imagery. In this time, you can also import it any kind of satellite imagery or drone imagery. And you also watch this video, then you can easily get the idea how it will work. And further, here you can see about that we are just simply make the level, okay, all of classes. So basically it's a one kind of supervised machine learning model. So for that, when you want to make the classification, you must need the pre-categorized data or label wise data. So just we make the label wise data, and further we are just simply import show the imagery with their label, and then you can get this. I create this type of model. So basically when you want to create this type of model, in this time we consider about the sequential model, and we create that convo 2D layer, max pooling 2D layer. So basically this type of layer help you to create that your hidden layer, okay, and also output layer. So just we add this type of layer, and all of description I already add my medium, so that's why you can easily get about that. Here you can see for input layer, also convolution layer, pooling layer, fully connected layer, output layer. So these type of things you can easily get it from here. And further also you can see about that the model summary, then you can get easily all of model summary. Mainly each layer output shape we can easily get from here, and also get their parameter number. Okay, and now we can easily find out the total parameter and trainable parameter, and also the non-trainable about that. And now this model we have simply compiled. Okay, so then further we are just using here the Adam. So not only for the Adam, if you want, you can also use here the other types of parameter. It can be your other type. You can see HGD or RM, SP, or ROP. So if this is there's a lot of optimizer is available. So maximum time we also use here the Adam for the classification purpose, image classification purpose. So just we are put here that, and further we just try to fit the model. So basically in this time we are just train the model. Okay, I compile this model, I simply call it, and then fit and put here the train image and train label. So basically these two things we are used for train our model, and also check the validation about that. We are just use the test image and test label. So these two things I already done. the previous for doing this. When I take the data set, I already done it. So just I put these things, then we can get this type of things. Further, we check the accuracy, and this accuracy we also try to use it, this type of things. So here again, so we can get this type of 65% accuracy about that. So my model is currently classified 65%. Okay, so when I import any kind of imagery, it automatically show me the result. It can be dog or frog or truck or bus. Okay, so it automatically show me the result about that. As well as also you can see application. Basically, after creating this model, we can easily convert the trained model to deployable format. Okay, integrate the GIS system or web GIS application for the real-time application. So now this model you can easily integrate in the GIS system or web application. So that's why when you want to import any kind of imagery, it automatically detect what is that. It will be cat or dog or anything. It can be show you the classification result, as well as use the model for monitoring the change in land use over time. Also integrate the decision support. Okay, there's a lot of uses about that. So further, I also try to create the lot of tutorial about that deep learning, as also talk about that CNN model or any other kind of model, how we can easily use. Okay, so for that you can simply keep in touch with my Medium. This is, you can easily get the lot of things about that. Also get the description about that, so it also help you to learning. Okay, as well as you can also connect it with my YouTube channel, also connect it with my Telegram group, also WhatsApp group. So then you can easily get all of information from here. And as soon as possible, also try to start the new series for that computer vision and artificial intelligence on satellite and drone imagery. So further, if you want, you can easily join with my live training session and also get all of practice code and also learn easily all of those things. So today is no more. So thank you for watching that. Stay happy, stay safe.